Today I would like to talk about synthetic assets on Bitcoin and Bitcoin-like blockchains. So, first of all, why would you like to have this? If you have some assets, you would like, well, to own them. That means to be able to store them securely, to transact them with anyone, anytime, without any third party being able to interfere with this. Also, you would like to have to keep it stable in value. And for your Bitcoin maximalists, if you consider Bitcoin stable, go talk to your nearest coffee shop, trying to get them to accept your satoshis without immediately converting to dollars. And you would like them to be not custodied by someone else. Because, well, technically, if they are custodied by any third party, they are not technically yours anymore. So popular solutions like Tether aren't very secure in this point. Also, well, why not? We would like to play this new fun game and being able to bet our precious Satoshi in DeFi casinos. Also, Bitcoin maxis would like, because it's not Ethereum. So, we would like to have a solution that would be able to create contracts and implement perpetual swaps, futures, options, conditional tokens, and this solution should be able to cope with adversarial attacks of any third party, including government-sized actors. Bitcoin gives us such a platform, since it's now our strongest first layer, but on a base layer, layer 1 of Bitcoin doesn't support any tokens. Also, you don't have smart contracts on Bitcoin, at least in not in Ethereum meaning of this term. You don't have a universal computer that computes your code, that executes your code. Technically, you don't have lambdas where your code would be executed. So we would like to have synthetic assets on Bitcoin blockchain, given these constraints. Synthetic assets, by definition, it's a mixture of assets that, when combined, have the same effect and value as another asset. For example, if you're in finance, if you sell a call option on an asset and buy a put option at the same time, at the same strike price, it gives you essentially the same effect as you own the asset itself. You have exposure to this asset, but you don't own it technically. Let's see how we can implement it on Bitcoin blockchain for a completely fictitious asset called Uganda shilling digitale, also known as USD with this curvy sign, and please don't confuse it with the United States dollar, at least for the meaning of this talk. Our solution should support following use cases: creation of synthetic asset, minting it, on-chain transfer, or either a complete contract or any part of this contract, destruction of synthetic assets, burning it, liquidation, and increase of collateral. Also, since we would like to have some fun, let's add lending and borrowing to this mix. What would look like a naive solution to this task? Say we have Alice that would like to fix her value of BTC at a price of 10k shillings per BTC at January 1st for 30 days. And we have Bob that wants to go leveraged long, 2x long on his Bitcoins for the same term at the same price. They could both deposit their funds into 2 of 2 multi-sig and have them stored on blockchain and have their contract valid of 2 Bitcoins. But when the contract expires at January 30, if price falls from the open price of your contract, losing party has really no incentive to cooperate. Why the hell Bob would co-sign a transaction that would return him just 0.9 of his BTC when he can hold LS funds hostage? So we have to introduce Carol arbiter. And let's see how that would work with the same setup. January 1st, we have our Bitcoin price at 10k per BTC. Alice would like to fix her value in USD. Bob would like to go long. They deposit both 1 Bitcoin. Both Alice and Bob deposit 1 Bitcoin in 2 of 3 multisig between Alice, Bob, and Carol. They should not involve Carol if they cooperate. If they do, Carol will earn small fee for resolving the dispute. That way, they have an incentive to cooperate. Same scenario, January 30, Bitcoin price falls. Alice suggests a transaction that would pay her 1.1 BTC and Bob leave Bob 0.9 BTC out of these 2 of 3 multisig, and they're both happy. Vice versa, if Bitcoin price rises and Alice is on the losing side, Bob can suggest Alice a transaction that would pay him 1.1 BTC and leave Alice with 0.9 BTC. They would both sign it and send to the Bitcoin blockchain. If they not, say Bob is on the losing side and he refuses to cooperate, or perhaps just offline, Alice can go to Carol and ask for a transaction that would resolve this contract. And Carol would happily create a transaction that would pay her 0.02 BTC, her commission, leave Alice with 1.09 BTC, and leave Bob, pay Bob 0.89 BTC. Same way, when price rises, Alice refuses to cooperate. Carol suggests the transaction that would pay her again the commission. Bob is on the winning side, Alice on the losing side of the deal. This actually can work any day, any time, not just in the expiry of contract. So what about our second use case? What if Alice at some point of time decides to transfer her value of 10k, 10,000 shillings to Dave? She can create a transaction that would pay the entire amount of contract to another multisig of Dave, Bob, and Carol. Go to Carol, contact Carol with a request to co-sign this transaction, and voila, transfer is done. If Dave sells coffee on a conference, Alice, same way, can ask Carol to cosign a transaction that would give two outputs of this multisig. First one would go to Dave, Bob, Carol, top 3 multisig with the value of 10 USD per double letter, and the rest of 9,990 or whatever would go to a new Alice Bob Carol multisig. So this way we can transfer fixed amount of value in another currency on Bitcoin blockchain. What if collateral is not enough on any side of the contract? Say today is January 11th and Bitcoin prices flash drops to 6K per BTC. If Alice and Bob cooperate, say Alice decides that the collateral is not enough to cover her side of the risk, she can suggest a transaction to Bob that would pay her 1.6 something BTC and leave Bob with 1/3 of Bitcoin. As before, if Bob refuses to cooperate, she can go with the same request to Carol. Carol happily takes her fee. And leaves Alice with 1.65 something BTC and Bob with 1.32 BTC. Also, this can work without Alice. I mean, without Bob. Say we have another participant, Frank, that have a spare 1/3 of BTC and would like to restore Alice's side of security in this contract. He can contact Carol with his UTXO. Carol can suggest a transaction that would pay out of original Alice Bob Carol 2/3 multisig to a new Alice Frank Carol 2/3 multisig with an additional input from Frank. This way, at this price of Bitcoin, Alice have again 10,000 shilling worth of her Bitcoins in this multisig. Her trust is restored. Frank, on the other side, earns his additional Bitcoins with 25% premium, which is nice, I guess. Of course, in this scenario, Bob loses it all, and he doesn't like it. So, day before, when Bitcoin price is not 6 but 7K per Bitcoin, Bob can contact Alice or Carol and say, hey, I would like to restore my collateralization level. Here's another Bitcoin of mine. Let's do another contract. If they do cooperate, they happily cosign. Alice and Bob sign a transaction. Original contract is closed. New contract is created. Again, Alice is completely secure. If Alice, for any reason, doesn't cooperate, say she's offline, she takes her rest on Bali. Same could be done with Carol's signature. Bob and Carol sign the payout from the original contract to a new multisig. Alice's side of the contract is restored, and when she connects back to the internet, she can query the history and get an address of her new multisig from Carol. This way, we can implement all basic primitives of synthetic assets on basically any UTXO-based blockchain without smart contracts. Those are create a contract, mint synthetic asset, destroy a contract, close contract, burn synthetic asset, transfer any amount of synthetic asset, liquidate a contract, increase collateral. With more complex multi-sig schemas, we can implement more complex structures like lending, either BTC or Uganda shilling. We can implement options, we can create conditional tokens, we can create whatever you would like. And this means synthetic anything. Not just Uganda shilling, which is completely fictionally structured. You can track value of any national currency, unless it will be declared illegal tomorrow, of course. You can track value of any asset. I don't know, price of oil, price of gold. You can track even what you can really measure, say network hash rate. Any miners here? Would you like, no? Miners would love, I guess, to reduce the risk of increasing hash rate by trading on such market. So, what would be a roadmap to implement such a project? First of all, we are going to implement it as a purely centralized but still non-custodial solution. There would be a single centralized arbiter, which would hold just one key or more keys out of multisig for more complex contracts on testnet. After this would be done and successfully tested, we would go towards technical decentralization by firing up several nodes and creating some consensus protocol between them. And then we will play with decentralizing governance of such protocol, do some simulations, and running testnets. What would not be done? I have no plans to do a mainnet release. Thanks, not me. I am not well equipped to bear a legal risk of doing such a project, especially with current state of regulations that could be introduced at any time and retroactively. Also, unfortunately, at least at this moment, it could not be implemented on Lightning Network. At least not until mainnet, Bitcoin mainnet would have Schnorr contracts, Schnorr signatures, and Lightning Network would have implementation of pay-to-point contracts. Current status. I have a kind of white paper which is more a collection of random thoughts and motivations of doing this design decision versus that design decision and description of a protocol. I'm doing a testnet implementation which would be ready in 2 weeks, quote unquote, which usually means someday. And if anyone is interested, just PM me on Twitter, and I would be happy to discuss. Thanks.